get started. Hi everyone. Thank you so much for being here right after lunch. I promise we'll get through the food coma together. My name is Anita Singh. I work and am based out of San Francisco and work for a small startup called Winnie, which is an app for parents. But today I'm super excited to be here to talk to you about fonts, emoji, and text. We're going to learn how to implement them with backwards compatibility, and we're also going to learn how they're implemented internally, which is actually quite interesting. So if you use text in your app at all, you're in the right place. More specifically, we're going to learn how to implement custom fonts in your app using fonts in XML and downloadable fonts. We're going to learn how to future-proof emojis using Emoji Compat, and how to have beautiful, readable, dynamic text using Textview auto-sizing. Something interesting to note is that a lot of them can work together. So Emoji Compat can use downloadable fonts. Downloadable fonts can be applied using fonts in XML. So hopefully at the end of this talk, you'll be able to see the bigger picture of how these different components can work together to not only improve your user's experience, but also improve our experience as developers, because they're actually make it easier for us as well. So let's get started. Of course, all the fun always starts in your build.gradle file. So make sure to have your support library dependency in there, and make sure it matches your compile SDK version for things to go smoothly. And the first topic is fonts in XML. As the name implies, it is a new resource type now in Android, so you can create a font folder under res and put all your custom .ttf font files in there, and then you can refer to it with the @font tag or r.font.font name, just like you would for any other resource type. So it's a really convenient addition to Android. And another thing you can put under the font directory is a font family file. And this essentially sets the relationship between text styles, the fonts, and the different weights. So when you typically use a font, in this case I'm using Lotto as an example, which is a Google font. In case of Lotto, you have Lotto Medium, Lotto Bold, Lotto Semi-Bold, Lotto Black, and you don't really want to use all these different font files throughout your layout, and so font family files sort of help with that. You can set up what exactly, when you say text style equal to bold, what font it should actually refer to, and that way you can just use the font family in your layout files and just apply the style, and it'll pick the right font for you. Something to note here is that you have to use both the Android and app namespaces for this to work on all versions of Android. Great, so now we have fonts and font family in XML, but why do we really need this? If you've ever used custom fonts in your app, you've probably used calligraphy or font binding third-party libraries, or you've done something like this, where you have a custom text view, and all it does is sets the font in the constructor, and then you use this custom text view all throughout your app. And this is actually why these third-party libraries exist, so you don't have to do this. And like, that's no fun, right? Having to use custom text views everywhere in your app just to use custom fonts is not fun. But luckily, we don't have to do that anymore, thanks to fonts in XML. Great, so how does it work? It works using the Android Asset Packaging tool and app compat. So when you compile with SDK 26 and above, it uses Android Oreo's version of apt, which knows to bundle, which understands fonts and is able to bundle them into resource files. And then the support library is able to read those attributes through the app compat layout inflation process and is able to load the typeface from those files that way. So as you can see here, it's a beautiful stack trace. Of course, as developers, we love our stack traces. But the reason I put this here is because you can see exactly what is going on right from when you do a set content view in your app compat activity in this case. You can see it goes through the layout inflator, the app compat delegate kicks in, goes all the way to typeface compat. And typeface compat has different implementations for different APIs. So there's typeface compat API 26, 21, and that essentially loads the typeface for you from the font files. So it's using apt and this app compat layout inflation process that Android was able to add a new resource type and have it be backwards compatible, which I think is cool. Great, so we know why we need it, we know how it works, but how do you use it? You can use it using a handy font family tag. You can either put a font family or a custom font. You can refer to either of those in there. And this next part is my favorite. Now to have all your text views throughout your app, to have your custom font, all you have to do is have one line in your app theme, and all your text views throughout your app will have this font. No more custom text views everywhere, no more third-party library dependencies. It's now just one line of XML, and so that's a pretty big improvement. And you can also get it programmatically using resources compat.getFont and apply it that way. Great. It's not Android development without its gotchas. So make sure to use both the Android and app namespace when you are using font family files in your XML that kind of bit people in the beginning. And as you saw, since it uses the app compat inflation process, you have to use app compat components, like app compat activity, etc. And some links for reading later. All right, next up, downloadable fonts. It essentially allows different apps to request a font from a font provider application, and that font provider essentially looks into its font cache, checks to see if the font is there. If not, basically downloads it from the internet. In this case, it uses Google Fonts font provider, which is part of Google Play services. I believe it's the only publicly available font provider right now. And the apps can do this using the fonts contract compat API to request these fonts from the font provider application. And this way, different apps can share fonts, which is really cool. Why do we need it? It results in a reduced APK size, which can actually have a huge impact on your app installs. And it also results in less memory usage, cellular data, and disk space, because can you imagine how many Roboto font files are in your phone right now, or Lotto, or any popular font? You have multiple of those font files in your phone right now. What if they could all just use one and share it? That's kind of what downloadable fonts is trying to solve. And if the users actually knew what you were doing, they would be really happy. They would be happy like this emoji with sunshine and rainbows, and you owe it to your users that they feel this way, right? That's our jobs. And yeah, there are actually two ways to implement it using this, to do it in a backwards compatible way. And one way is to do it programmatically using the support library. So to do that, you can get started with having a font request. You pass in where you want the font from, which in this case is Google Play Services. That's what gms.fonts refers to. You pass in the font that you want, which in this case is Lotto, and there's a certificates file which Android Studio can generate. It allows us to not get fonts from unknown sources, which is really good. And then you have your callback with your success and failure, and in the success, you can set your typeface. And then you want to have a handler. You do not want this to happen on your main thread. I think if you try to do that, it'll actually crash. So definitely try to not do it on the main thread. And then you can put it all together with fonts, contract, compat.request font. And you can pass the font request, the callback, the handler thread, and when the font is downloaded or retrieved from the cache, you will get the on typeface retrieved callback, and if something fails, you will be informed. What you saw is cool, but you probably don't want to do that in every activity or fragment or view groups, whatever is cool right now. So I actually recommend using Android Studio and fonts in XML because it's actually a lot less work, and it allows the framework to prefetch fonts, which I'll get to in a bit. So if you want to go down this route, just select whatever text view in your app, select font family, scroll down to more fonts, click on that. On the left here, there's only Google fonts available, so to find the one that you're looking for, make sure to have create downloadable font checked. And if you do all this, 3 files gets downloaded. The first one being lotto.xml. This is similar to the font family file that you saw earlier, except this contains the attributes to load the font from a font provider instead. So as you can see here, it has the authority, the package, which again in this case is your GMS fonts. You have the query, which is Lotto, and something worth pointing out is that you can specify the font provider fetch strategy, which can either be async or blocking. And async is the default. You might be wondering, well, why would I ever use blocking? If you're using a custom view that is not a text view, and it implements the font family property because maybe you are drawing some text or something like that, blocking can actually come really in handy, because if you do async, it won't work. And that's because the framework or support library basically fetches the fonts, and in the async callbacks, it updates the text view with the font. But if the custom view you're working with is not a text view, that call will actually fail. You will not see the custom font, and so blocking makes it synchronous. And if you're using it in fonts in XML, it will get the font and use it as soon as it's ready instead of having callbacks. And so it's useful there, and it can also be useful for debugging. If you make it blocking and it suddenly works, you know there's something wrong with your callbacks. And so something to think about. The font _certs essentially contains the certificates for your prod and dev environments, and helps us avoiding getting fonts from unknown sources. That would not be fun. So that's generated by Android Studio as well. And this is actually pretty important. Another reason I recommend using fonts in XML and Android Studio instead of doing it programmatically. You can actually pre-declare your fonts in this file, and if it's referred to in the manifest, the framework will try to fetch the fonts as early as possible during app launch, because you don't want it to fetch fonts during the first layout pass. That might be too late. You might see 2 seconds of Roboto before you suddenly see your custom font, and we don't want that as much as possible. So this allows the framework to prefetch the font. It's not guaranteed that that won't happen, but it reduces the likelihood by a lot. So highly recommend using this. So as mentioned, it needs to be referred to in the manifest file. Android Studio will automatically add this, but definitely check. And if all of this is done, you're ready to apply the downloaded font. And you can do that using fonts in XML. Again, 1 line of code in your app theme, and all the text views in your app will get the font. So pretty easy, and most of the files you just saw would be auto-generated by Android Studio, so the work is definitely reduced. Great, so what are the gotchas? You have to use Android Studio 3.0 and above. Hopefully you already are to generate the font files. You have to use Google Play Services 11+, which I think is one of the latest ones, for downloadable fonts to work with the Google Font Provider application, which again I think is the only publicly available one. This might sound like a deal breaker, but actually Google Play does a pretty good job of making sure devices have the latest version of Google Play Services. I think it updates it every 3 weeks or so, but that being said, they will definitely be users who don't have Google Play Services or have outdated ones, so you definitely want to think about them. My recommendation here would be to have your text styles. If you're going to rely on custom fonts for all your styling and you don't use like text styles like bold, italic, then the folks without Google Play Services will just see all unstyled text. So make sure as much as you can to use text styles. So even if they end up seeing system font or Roboto, it still looks okay. And there's support library version 27.0.2 has a kind of a deal breaker crash. So support library 26 and 27.1.0 is good, but just wanted to point that out in case you have to use that one. So when you're using downloadable fonts, if you do resources compat.getFont, it might throw a resources not found exception because your font may not be downloaded yet. And so definitely make sure to handle that. You can maybe get it programmatically if it fails. And just something to keep in mind. So if you're using a custom font that is not a Google font, you might be out of luck. You'll have to implement your own font provider, which I don't think has public documentation yet. But I mean, this is only worth it if you want to share fonts between different apps. So maybe you're Adobe or you're Uber and you have different apps and you have your own custom font and you want them to share it, then it might be worth looking into it. But if it's your own thing that no one else is using, it's not that useful to the user. And this is very good for the user. Fonts are very persistent once they're downloaded. But it's kind of annoying as a developer because once it's there. Like clearing Google Play cache does not clear it. So I've put the location of the font if you have access to a rooted device and you want to retest the download. go in there, delete the font file, make sure you clear Google Play Services cache, and make sure you also clear your app data, because in certain versions it copies the font file over to the app space. So if you want to retest the download, you can have fun doing this. And yeah, that covers downloadable fonts. Next up is emoji compat. Who doesn't love emojis? So essentially, emoji compat has classes that allow us to provide backwards compatible emoji support for our users, so that they don't have to see those little squares of sadness. They're called tofus. When you don't see an emoji and you see that little square, it's actually really sad. Like, what did your friend mean? It could be so much miscommunication, and that's essentially what emoji compat is trying to solve. Why do we need it? Well, essentially, with emoji compat, users don't have to update their operating system to see the latest emojis, which is great because Android people are not very good at upgrading their operating systems, and sometimes they can't because of the hardware. Looking at you, Android P. And yeah, so now even your KitKat users can have head-exploding emojis, tacos, and unicorns, which is great. That's a whole new world for them. And yeah, how does it work? So emojis are represented by represented by Unicode code points, and emoji compat is able to identify those and check if the system font can render it. If it can, great. If it can't, then it replaces the emoji code points with emoji spans. And these emoji spans are basically replacement spans. And replacement spans allow us to replace char sequences with customizations. And this emoji span has an emoji metadata object, which can essentially render the emoji glyphs using the support font. And so it's because of this whole replacement process and the support font that the Android is able to provide backwards compatible emojis to up until KitKat, I think. So yay. The library components, we just discussed emoji span and emoji compat font. There are also widgets like emoji edit text, emoji text view, emoji app, and the app compat variants that will render emojis out of the box. You don't have to do anything special. And then there's actually two ways of configuring emoji compat. The first being downloadable fonts. The first dependency is for regular text views and such. The second one is for app compat components. And you do something similar to what you saw earlier. You have a font request, except in this case, you are passing Noto color emoji compat, which contains the latest emoji for Android, and you pass in the certs. And then you have a config object, basically the font request emoji compat config. And then you have the oninitialized and onFailed callbacks, and you have to call emoji compat.init with this config. You want this to happen as soon as possible in your app's lifecycle, so I put this in the application class, and it works. And if you want to do preloading for emoji compat, like we saw with downloadable fonts, there's a handy font provider requests tag that Google Play Services reads at either install or update time and initiates the emoji font download then. And that's great because it really increases the likelihood of the font already being downloaded by the time you launch your app. So you don't have to see the tofus of sadness. Something worth pointing out is you can actually pass in any downloadable font here, but this method is actually recommended for preloading for emoji compat versus what you saw earlier for downloadable fonts. And that's because we want emoji compat to make the decisions of when to load the font rather than the app doing it. And I think this isn't actually in the Google Font Provider documentation, and it was just recently added to a Medium post by Google. So just heads up, if you Google this, you may not find it. And I don't want you to think that, oh my God, that speaker just like lied to us. I tested this, it works, it initiates a download at install time. So have fun. The other way to use emoji compat is through bundled fonts. And this essentially adds the emoji font to the APK. And you can set it up this way using bundled emoji compat config. Something worth noting is this optional property called set replace all. And you can also use this with the downloadable fonts config. It essentially replaces every emoji glyph that it finds with the one in the support font. So this way you can have consistent emojis across your devices. So if you don't like the ugly Samsung emojis, you could use this and everyone could have consistent emojis, which is pretty cool. But something to note is that this adds around 7 MB to your APK, and users will have to update your app like every year to get the latest emoji. However, it doesn't depend on Google Play services. There's pros and cons to both approaches. Do whatever's best for your app. This is using emoji compat. You have your emoji text view, emoji app compat edit text. These sort of work out of the box and render the emojis. Well, let's say you want to work on a widget that is not the ones that are out of the box, like text input edit text. There is this handy method called compat.process. It's actually emoji compat.get.process. So what you do is you listen to when emoji compat is initialized, and once it's initialized, you can call the process method, which basically replaces the char sequences with emojis. And so you can apply this to any widget that can render spanned instances. And definitely think of the on-failed cases. And sometimes I see that people only set their text in the on-initialized, and they don't set text at all if it failed. Seeing tofu is kind of better than not seeing text at all. So something to keep in mind. Oh yeah, and of course, unregister your callbacks. So if you want to use it with custom widgets, you can use the get process method that we just went through, but there's also emoji text view helper and emoji edit text helper classes that can help you out. But I've included a code sample of this in the slides, but won't be going over it if you want to check it out. But just know that they're there for you. And let's say you're working on a keyboard, you definitely do not want to show an emoji that the app cannot render, right? And so there's a handy has emoji glyph method. You can pass in the metadata version by looking in the editor info.extras bundle, and that way you can configure your palette and only show emojis that the app can render, which is also useful. All right, so gotchas. It's API 19 plus, but you can still use it if you're supporting lower operating systems. It's just your text views will behave like regular text views. The process method that I mentioned only works on widgets that can render spanned instances. So we saw that it could work with the text input edit text, but for example, if you want to put an emoji in the hint, this method will actually fail because it doesn't render spanned instances. And again, like I mentioned, make sure to handle the failure cases. It's better to see tofus than no text at all. And of course, if you're using it with downloadable fonts, all of its gotchas apply, like being dependent on Google Play services. Yeah. And the last one, TextView auto-sizing. So this essentially gives us the ability to instruct text views to either expand or contract text in order to fill its layout. So as you can see here, it's dynamically either expanding or contracting to fill its bounds. And we can set the constraints for that. And well, why do we need this? Actually, material design has recommended using dynamic text types instead of smaller text or truncating text for a very long time, but now we can actually do it with their support. As you can see here, you have text. When the text is smaller, it's bigger, it's more easier to read, and then it sort of auto-sizes to still fill the same space, but it either contracts or expands the text size to fit it in. And so this allows for shorter text to be more readable, and have your layouts to sort of be uniform. You don't have to truncate text or compromise on text sizes anymore. So how does it work? Whenever text is set or changed, or whenever you set TextView auto-sizing using TextView compat, there's an auto-size method that lives in the app_compat TextView helper classes that is called, and it essentially just uses binary search to find the largest allowed text size that it can set the text to. And so in most cases, that's pretty much it for how TextView auto-sizing works. And you can use it using the handy auto-size text type attribute, which you can set to uniform or none. There are optional attributes like auto-size min text size, auto-size max text size, and the granularity. So this basically sets the min, max, and the step size. It's optional if you want to specify those. There's also auto-size preset sizes, which you can specify the sizes, and it will only choose one of these using the binary search that I mentioned. But just note that you have to set auto-size text type as uniform for any of this to work. And there is also API for this. So TextView compat.set auto-size text type with defaults. You can set the auto-size text type that way. You can set the granularity, the min and the max. You can set preset sizes. These are pretty long method names, like what is this, Objective-C? But it does the job, so that's what's important. And these are the min, the max, text size, and the granularity, the defaults if you don't set it at all. All right, last slide. The gotchas, API 14 plus, which I think is okay. Do not use wrap content when dealing with TextView auto-sizing. Either use match parent or use set text sizes. Otherwise, you can have unexpected results. In my case, it just didn't work. But it needs to know bounds in order for it to expand and contract. So make sure to set those. TextView auto-sizing is kind of a new world. You might think that the text will auto-size to fit the word in one line, but instead it'll try to fill the space and maybe unnecessarily make a word go to the second line. If you have text views sort of close to each other, it can only expand uniformly, so you might think it'll take the whole space, but it won't, and then you might have different space between views. So definitely make sure to test, think of what the minimum it could be, the maximum, so you don't end up with awkward looking layouts. And if you're not using app_compat components like app_compat activity, you can just use app_compat text views. That wraps up this talk. I think we have some time for questions. Any questions?
you mentioned there's a font provider fetch strategy.
Yes.
Which is like could be handy for custom use. So I guess how it works. Let's say you have custom view that, let's say, inflate like created during the application launch and does some like text rendering. And if you use blocking, it'll basically not render the view, correct? Until the font loads?
Yeah, if it's a custom view that is not a text view and implements the font family property, in that case, yes.
If you use like asynchronous fetching strategy, is there like a callback so you can listen when font is available so you can invalidate views?
I don't think so, but if you want to do it asynchronously, you could do it programmatically. You don't have to use blocking in this case. You can still have callbacks. You'll just have to use the programmatic way of doing it. But if you want it to work in XML, for that case, blocking is what makes it work. If you use async, because if you use async, the callbacks won't work.
Yeah, another question I had, if that's fine. So you mentioned there's a crash with downloadable fonts.
Yes.
Can you tell what
yeah. In API 27.0.2, if the app is installed with very low internet connectivity, it will time out, and when that happens, your app will crash. So it's actually a pretty big crash.
Yeah.
We actually released with it and had to roll back to support library 26 because I mean it's not very common, but if people do install or launch apps, the first launch can be under low internet connection, and if that happens, it would crash. But it is fixed in 27.1.0, and it's fine in support library 26.
Yeah, well, I'm asking because I had the similar crash.
Oh.
Basically, I've crashed when I used downloadable fonts and web views. So when I open web views, it crashed. So I rolled it back a long time ago, probably with the support library to make things that.
Yeah, sometimes they have their crashes and their issues.
Yeah. Thanks.
Yeah, of course. Any other questions? All right, well, I hope you'll take advantage of these new text changes that were introduced with Android Oreo. The more apps that use downloadable fonts and emoji compat, the more benefit it is to the user. Remember the rainbow sunshine? That's what we want our apps, our users to feel like. And yeah, thank you so much to the organizers of Android Makers for having me. They've done a fantastic job. And shout out to Siamet and Clara from Google. I kind of bothered them a bunch. And thank you so much for being here. Enjoy the rest of your conference.